Hi everyone, my name is Hilde Weerts, and in this video I will present our paper, Can Fairness Be Automated? Guidelines and Opportunities for Fairness-Aware Automated Machine Learning. This was a joint work with many lovely people, most notably Florian Pfisterer, who is the first co-author of this paper. So over the past couple of years, it's become quite clear that while machine learning systems can be very beneficial, they can also produce some unfair outcomes, resulting in algorithmic unfairness and discrimination. So this ranges from public welfare systems, recruitment, image recognition, criminal justice, to education. So this has given rise to the field of algorithmic fairness. Within the computer science research community, the by now traditional approach to tackle fairness is to formulate it as an optimization task. So essentially, you want to try to achieve a high predictive performance while satisfying some kind of fairness constraints. Most of the popular fairness metrics and constraints quantify the extent to which some form of equality between group statistics is violated. So for example, the equality of selection rates across genders or accuracy across different racial groups, etc. And for this purpose, researchers have come up with various different types of algorithms or fairness-aware machine learning approaches that resolve this optimization task. So these are typically subdivided in 3 different categories. So you have pre-processing algorithms where the training data is adjusted to somehow obscure undesirable associations. We have constraint learning approaches where fairness constraints are incorporated directly in the machine learning process. So for example, through some different types of regularization, and post-processing approaches, which adjust a trained machine learning model or the predictions of that machine learning model. And like many subfields of machine learning, AutoML has also dipped its toe into fairness-aware research. And in fairness-aware AutoML specifically, researchers have started to propose AutoML systems through multi-objective or constraint optimization over existing fairness-aware machine learning techniques, as well as different types of neural architecture search and hyperparameter optimization to try and optimize for fairness. And compared to traditional fairness-aware machine learning, there's a couple of advantages of fairness-aware AutoML. So first of all, AutoML generally reduces the barrier to entry, and in this case, the barrier to entry to fairness work. It would also allow users to find custom solutions that best fit the problem at hand, because an AutoML system typically looks at many more options than a single machine learning practitioner might be able to do on their own. However, there's also a burgeoning body of interdisciplinary research that shows that formulating fairness as an optimization task is not always effective in achieving fairer real-world outcomes. So in this paper, we asked the question, can fairness actually be automated? And many of the limitations and challenges, but also opportunities related to fairness-aware AutoML are very much related to the scope of AutoML systems. And most AutoML systems today focus primarily on the modeling stage of a machine learning workflow. However, the biases that are at the source of fairness-related harm can arise in each step of the modeling process. And because of this, the effectiveness of fairness-aware AutoML systems highly depends on the way in which we configure the system, but also on the user input and the interaction. And we will discuss several components that are quite important in relation to fairness-aware automated machine learning. And we're going to start with some items related to user input and interaction. So first of all, there is the data. So data sets are notorious for having biases encoded in them. So for example, data sets can encode historical disparities. They can be disproportionately inaccurate or uninformative or invalid for different sensitive groups in society. I would like to emphasize that data on its own is definitely not the only source of fairness-related harm, but it is quite an important one. AutoML systems could also flag potential issues to trigger, for example, a user interaction and incorporate tools to help mitigate biases in data sets directly instead of trying to resolve it afterwards in the modeling stage. The second major user input is the fairness metrics that we are actually trying to optimize for. So I won't dive too much into the details here. And if you're interested, I definitely recommend you to read the paper. But essentially, fairness metrics are very simplified formalizations of more substantive notions of fairness in the humanities. And because of this, we essentially run into Goodhart's law. So when we try to enforce a fairness metric, instead of just using it for assessment, this can have detrimental side effects. And when it comes to AutoML systems, it's very important that we make practitioners that use these systems aware of this and encourage them to exercise a lot of caution and thoroughly scrutinize the models beyond simple metrics. Finally, when it comes to user input and interaction, we have system use. And like any system that tries to automate particular components or offer user decision support, fairness-aware AutoML systems are susceptible to automation bias. So for example, users can overtrust some of the suggested models of the AutoML system and maybe also disregard alternative interventions beyond the modeling stage simply because they're not included in the AutoML system that the user is using right now. So when it comes to the design of AutoML systems, it's important to encourage practitioners to take an active and engaged role, for example, by introducing some forms of intentional friction, maybe user prompts, or extensive documentation. And in this way, we can try to move the user from a more passive role to the active role that's required for fairness work. Now let's go to the system configuration. So this could, the first part is the search space. So the search space implicitly determines the types of algorithms and processing steps that are to be considered. And if not designed thoughtfully, this could result in undesirable models. It could also allow for codifying best practices. So it's both a little bit of a double-edged sword. And the implications for the design of AutoML systems is that the API design should allow users to make an informed decision on which components to include or to exclude in their search. A second component is the way in which we formulate the optimization problem. So most traditional work in fairness-aware machine learning has focused on constraint optimization, which is relatively simple, but also less flexible compared to multi-objective optimization. So when it comes to AutoML systems, new research could explore, for example, constraint multi-objective optimization, which allows for a better understanding of the different trade-offs between metrics and the effects of various design choices. Then there's the evaluation protocol. So the robust evaluation of fairness-aware AutoML is complicated by the evaluation of multiple metrics, like the predictive performance, but also fairness, as well as the small sample sizes of sensitive subgroups, especially if you consider multiple sensitive features at the same time. So when we design an AutoML system, we could, for example, flag potential issues to the user and incorporate some best practices in evaluation. Fourth, there's benchmark-driven development. Existing fairness benchmarks are almost always decontextualized and very limited in scope, and this can result in misleading claims regarding the real-world impact of the tested methods, as well as blind spots for the different capabilities that a system might have beyond the modeling stage. So if benchmarks are used, the dataset should be contextualized, reflect real-world challenges, and also be sufficiently large. So all of this is a very long way to say that actually fairness cannot be automated, and instead we really need an iterative, context-sensitive process that's guided by human domain experts, because this is the only way in which we can actually achieve fairer outcomes. So what does this mean for the typical AutoML researcher? Well, it does not mean that you cannot contribute to the research field of algorithmic fairness, because there's many different research directions, which we also list in the paper, that AutoML researchers could look into. So this ranges from the development of more robust evaluation protocols, exploring constraint multi-objective optimization, using fairness-aware AutoML to learn about the fairness-aware machine learning process, and collaborating with other researchers in different fields to design better benchmark problems and to explore user interaction with AutoML systems. Thank you for watching, and I hope you have a good time at the conference.